The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. Welcome to this month's Rancher Online Meetup. This is Shannon Williams, and hopefully we've got a great crowd attending this month as usual. I hope everyone can see my screen, and we're broadcasting live. The meetup this week or this month is really focused on kind of an interesting problem. We're going to be talking about, how to build sort of a soup to nuts implementation of Docker for your team. I think for purposes of the meetup, we've talked about this as Docker as a service, how to deploy Docker, how to get it up and running with all of the back-end services so that you can actually start doing a lot with it. So for today's meetup, I'm joined by my co-founder here at Rancher, Darren Shepard. Darren, you want to say hi?
Hi, this is Darren.
All right, Darren is in Arizona. I'm in California. We're going to be bouncing around and talking a lot about technology today, talking about Docker, talking about systems like how to build using Docker containers, how to deploy applications with Compose. We're going to be talking about monitoring. We're going to be talking about GitHub. So hopefully we'll cover a lot of interesting topics that are useful for you. We're going to be, as always, getting into the weeds and answering your questions. So if you haven't attended a Rancher Online Meetup before, we hold these, pretty much every month. They are a little different than your typical online webinar because we really do try to take the time to discuss these topics in some depth and go over examples, answer questions, get feedback, and they tend not to have a prescribed amount of time. So we sort of roughly say they'll take about an hour and a half or so, but very often due to the number of questions they go long, and we never leave until all the questions are answered. So what we try to do to make that helpful for everyone that does have hard time stops is we try to get through as much of the content as we can in the first hour to 90 minutes and show as many of the demos as possible, and answer and ask questions as they come along. And then, we make a recording of the whole session available to everyone afterwards. So if you have to leave early, you can't stick around, this is being recorded, so you can come back later and watch the last half hour or so, at your leisure. As a meetup, we do kind of take a few different a little bit of a different approach to your typical webinar, and that means that we really do kind of ask you to be aggressive with your questions. Talk about the actual technology. Dig into anything that may be confusing or that you feel like we glossed over, or challenge our assumptions. There's a little question tab on the device. I can see people are already asking questions. So after as you get questions and you want to ask them, they're in the little panel. Feel free to fire away questions. I will be, reading them out for you as you go when Darren's talking, and Darren will be interrupting me when I'm talking to make sure that we address any really pertinent questions as they come up. And if I don't ask your question right away, I'll definitely get to it at some point. Maybe it's something we're going to address in a couple slides or in the next demo session, so I may put it on hold for a couple minutes to keep the flow moving. But we will certainly be doing all of this over the course of the next hour, and if for some reason we can't get to your question, we'll respond in an email afterwards and make sure we do get to it. As a meetup, we don't just do slides, we do demos. We do a lot of demos. Today we're doing, we're breaking the demo into 3 stages because we're doing so much. We're going to be really doing a lot of building and a lot of demoing today. So, I'll be talking a little bit about what we're going to show, and then Darren's going to jump in and actually show it. But because of that, be prepared. Things go wrong, networks go down, all sorts of craziness happens. So bear with us. We will, you will be living it with us as we run into problems and try to overcome those. So don't expect perfection, but expect that we will be showing you real stuff and how it really works. The other half of that is just keeping the slides to a minimum. We really try to use slides to kind of explain architecture, showcase, what's happening, what we're trying to accomplish, so that it's clear. But you're not going to get a lot of marketing slides and a lot of, kind of pitches for why, why Rancher is the greatest thing in the world. We really just want to get into how people can use this stuff and how pieces work together. And then, it wouldn't be a meetup if we didn't give away a few things. So, this week we're going to be, we typically give away shirts. We put them in the mail to people who kind of tweet about the content that's going on during the meetup. So if, today we're going to be I'm going to be the judge, but we're going to be, sending out shirts to the 10 most interesting posts on Twitter. So we usually do kind of the first, but this week I want to, we've been getting so many that I want to be able to judge the quality. So flattery will get you far, but interesting even further. So feel free to, to get involved, meet each other on Twitter, throw the hashtag up there and start a conversation with one another in the background. It's hard for me to track those during the meetup, so it's hard to respond and call out questions you have there. So if you have questions, please use the question tab. But otherwise, we'll certainly respond to anything you post up on Twitter afterwards, after we have a chance to read it all. All right. Without further ado, what we're going to talk about today is really, building this idea of kind of Docker as a service for your team, and we're breaking it into 3 phases to try and show different components of the actual life cycle of this service. First, I'm going to talk a little bit about what we mean. What is actually a Docker as a service? What is this thing that we're going to try and set out to build? And I'll show you the architecture and kind of how we're going to build it. Then I'll walk through 3 different phases. The first phase being building the core platform. The second phase being how to do builds and testing of software using the platform once we get it in place. The third being, how to actually roll out the apps. And then Darren's going to be, in each of these stages, he's actually going to be setting this stuff up. So in the beginning, he'll demo how to deploy out, the core platform. He'll then, be using Jenkins and spinning up some builds and running some tests and showing how we actually deploy against the platform once it's in place, how teams work on things, and then we'll be rolling things into production and sort of showing the difference between test and build and production and how you might think about things like monitoring and upgrade. So the idea we really wanted to encompass in this was that, as people are getting excited about Docker and they're starting to use it for components of their service, there's really an end goal that a lot of users have talked to us about, and a lot of the beta people that are testing Rancher right now and are putting it under pressure and starting to use it are really kind of looking at a broader goal, and I would call it really containerization of the entire development and operations process. So from the point of committing code into the code repository through building and containerizing the application to running tests, to actually deploying and upgrading and operating the actual application in production, there's a lot of value that Docker and the Docker ecosystem delivers throughout that cycle. And when we talk about a Docker service, what we're envisioning is really a fully integrated platform that enables this pipeline to happen and enables your users to really compress this pipeline down so that each component can be automated. Each component can benefit from sort of the immutable nature of Docker, and so that not just one developer but an entire team or a group of users can collaborate through this process. And there's no one magical piece of technology that does this today. There's a lot of cool things that are happening that come together to make it possible, and there's many ways to do it. So, but when it's achieved, the benefits are pretty astounding, because if any of you were able to attend DockerCon or was able to watch some of the wonderful presentations that happened during the user track, what you heard was organizations that really shrank even their sort of aggressive cloud provisioning times, sometimes by days and weeks, and we're able to move to just dramatically quicker build processes, dramatically quicker release cycles, and getting a lot closer to that continuous delivery target that a lot of DevOps teams have. And so, when we talk about building a Docker service, the benefits we're looking to achieve are really self-service for users, the ability to, kind of test more accurately against the replica of production, collaboration through, between both the dev and ops teams throughout the process, standardization of the integrations between these different pipeline components and automation of the pipeline process. We're looking at how to benefit from the density and speed that containers are giving us, and that means improving build processes, improving deployment processes, improving upgrade processes, and then from top to bottom, how can we sort of build on the immutable nature of containers to deliver a repeatable DevOps process, and as part of that, drive down the costs. I mean, over and over again when we're talking to people that are rolling out these tools, what they're telling us is that they're getting just a lot more density out of their spend in the cloud or in their data center. They're able to actually justify significant improvements to operations, but also cost benefits to using this type of technology. And it's still rough. I mean, a lot of these numbers are, I don't think we're at the point yet where we have concrete numbers about what this is what this impact is, but it's pretty obvious when you listen to the case studies that the benefits are very real for the users. So that's what we're trying to set out today to do, is build this entire thing. And we're going to use a sample application to do this called Let's Chat, which Darren is going to be setting up. Let's Chat is it's a simple Slack-like open source Node.js application that I personally think is pretty awesome. It is really just two components. It's the application and a MongoDB backend. You can download it and follow along if you want. If you just go into GitHub and search for Let's Chat, it's a great little thing to spin up, and it's especially nice because they've built it with a Docker Compose file. So we start with a nice Docker Compose file you can see on the right-hand side here. So Let's Chat is what we're going to be building today as a sample application to take through sort of the pipeline. And as when we talk about the pipeline, we are going to be putting together a stack of technology. And when Darren and I sat down to do this, we had a lot of options for the different components that we could use to build this stack out. There's competing pieces of technology and that handle lots of different roles that we thought were critical. So we had to make some choices. We picked things we were familiar with or that we thought a lot of people might be using to try and make this as general as possible. So we started by saying we really need to have a repository, so we're going to use Docker Hub to do that, and we're going to use that for lots of different components in this. We need to have a tool for obviously our code repository, so we're going to use GitHub for that. The the side benefit is we're also going to use GitHub for user and team management. A lot of users are pushing kind of using LDAP or AD internally, but for something simple and trying to get this all up in an hour, we're going to use authentication from GitHub, which Rancher supports. Then we're using Rancher to handle orchestration and to handle the infrastructure services like networking and load balancing and service discovery and all the things we need to actually deploy out our environment. We're going to use Jenkins to deploy the CI system. So as we do builds and as we run tests, we're going to have all that in Jenkins. And then finally, when we roll this into production, we want to show kind of adding on additional production capabilities like monitoring or logging and stuff. So we picked Prometheus, which we've done some blogging about. We think it's pretty cool. It's a great open source container monitoring service. So we're going to show how you might use something like that. Any of these can obviously be flipped and used as use some other piece of technology that you're interested in that makes sense as you think about what your sort of pipeline stack looks like. But this is what we're going to start with. And in phase one, the first three components we're really putting together we'll start with the Docker Hub. We're going to use Docker Hub as a repository. So we chose Docker Hub because because it's such a great public repository, and as they've just continued to improve the private repository capabilities. For this use case, we're going to use private repositories. So we needed to get something that we would actually go pay for, and we had an option of deploying something locally, but we decided to use a cloud service, and so it came down to a couple options that offered sort of hosted container registry, and we decided to go with Docker Hub. So you can sign up for something like this just directly from Docker's website. It's really easy to get going with Docker Hub. So this is one of the easier parts of our service because we're just going to sign up for an account. The other big registry we're using is GitHub. So with GitHub, we're going to use we're using again a private repository just to because I think that's what most users will actually consume. For this, we're going to use it to obviously store our code for whatever we're building, and then we'll also put up their compose files for different things that we do over the time. So Docker compose files will be kept in GitHub. And we're going to use it for, as I mentioned earlier, we're going to use it for user management and team management. GitHub is a great collaboration tool, and it sort of naturally has users broken down into teams and collaboration groups that are aligned with applications. And so it fits really nicely into how users will work together. And so throughout the beta and throughout the alpha of Rancher, we've just supported GitHub as an authentication method to define who can access different environments within Rancher. So we're going to be using that today. If in most deployments, you actually probably will connect this into your directory services like LDAP or AD. But to keep things simple, we're just using GitHub. And then, both of those will be linked into Rancher. And Rancher, we're going to be using to do a number of things in this, from managing our hosts to managing Docker, to implementing sort of Docker networking and storage and load balancing services, and the infrastructure services that Rancher is built to deal with, to handling provisioning of things like that. And then we will be connecting it to GitHub and Docker Hub, as well as we're going to need some hosts to run all this on. So we're running hosts. I believe Darren's going to run them all in Amazon, although we'll see as he goes along. But these hosts could really be coming from anywhere. We're going to, on all of these hosts, the things we really need are obviously the Docker daemon. So we're going to have some VMs or physical hosts running the Docker daemon. And then once Docker's running on them, using whatever OS that you want to deploy to run Docker, you can then deploy the Rancher agent on them. So once you run Rancher agent, Docker run Rancher agent, that will come up. So we have two cloud services. Rancher itself is a container in this case. So Rancher, I've kind of put it in a box to indicate it's a container. It can be running wherever you want to run it. And all the services that we create going forward are going to be beyond Docker Hub and GitHub will be actually deployed containers. So this is what we're building out to start with. This core platform that we'll be using as we go through the rest of the day. And I want to turn it over to Darren now to show you actually how we're going to do all of that. So let me make Darren the presenter. Okay, Darren, do you want to share your screen?
Okay, I should be sharing my screen. Can you see that?
I do see it. I see go to webinar.
Okay, good. You should be seeing that console now. Okay, so yeah, so as Shannon mentioned, so in this demo here, we're just basically going to build up the base environment. So pretty much set up Rancher, add some hosts, set up some credentials, and just basically get the kind of the core platform in place so that we can then start deploying applications and doing the CI and everything. So we're going to be demoing really a lot of things. So hopefully this all goes well. Might see some live troubleshooting, but yeah, cross your fingers. So the very first thing we're going to do is we're going to get Rancher running, just the server. So as Shannon had said before, the Rancher server is actually just a container, so it's really easy to get up and running. If you look at my screen there, so it's just basically Docker run 8080. We're just going to expose port 8080, launch that in the background, and so Rancher server. Okay, I'm going to do logs so we can watch this thing start up. The very first start of the server might take, a minute or so. Basically, what's going on is it's setting up a database. So Rancher is backed by a database, MySQL right now, and so there are different deployment scenarios where you can externalize the database. You can set up SSL. You can do a multi-node deployment. We have instructions for pretty much all those different approaches. But in the kind of the simplest setup, basically we run the Rancher server and MySQL in the same container in volume, so you can still do upgrades and things like that. So I was saying, as it's coming up, this might take like a minute or two. Right now, it's basically setting up the database schema. So once we have this up, we'll then look at adding. Or the first thing we'll do is we'll set up the GitHub authentication. And as Shannon mentioned before, the GitHub authentication, that's what we currently support. We have AD and LDAP in the works right now. So, a lot of people are asking for that, to work internally. Okay, so it looks like the server is up now. Let me just bring this up. I already have the URL here. So it runs on port 8080. So you hit it, it's up and running. So you can see at the very top we have this access control is not configured. So basically, let's configure that. So it's pretty simple. We made it really easy with GitHub. The instructions are here. So basically, we're just going to click on this link. It will bring us over to GitHub so we can set it up. We do have support for GitHub Enterprise. If you're using that, you just pretty much need to put in what's the host, like the URL of your private GitHub Enterprise, if you don't want to use public. Right now, we're just going to use public. Once we get to the form in GitHub, we're going to have to copy and paste these URLs, so I'm just going to copy it now. So I click here. This brings me over to GitHub. This is my own account. You just need to register a new application. We'll just call it Rancher Demo, and you just need to put these URLs in place.
Darren, if someone asked why you didn't use the SSL connection for this, Silvio Danianti.
So the SSL right here.
I think so.
So yeah, so right now, so this setup, like when you just do Docker run, we don't have SSL turned on. So there are steps, like we have that in our docs to turn on SSL, but right out of the box there is not SSL. I think we're probably going to switch that, so out of the box it'll be SSL with a self-signed certificate. But obviously, if you want proper SSL, you do need to provide your own certificate, and set that up.
Great, thanks.
Okay. Great, now I have a technical issue. Can you still see my screen?
I can, yeah. It seems to be frozen though. It's not like your mouse isn't moving around.
Yeah, my mouse is not moving.
Not very far along to hit an issue.
Yeah. Let's see if it comes back in a second here.
While you're doing that, one of the questions that came in, while you sort of work through that, someone was asking if there are any best practices for managing instance-level configuration as it relates to immutable deployment. So the assumption behind the question is that some configuration data will vary across a particular container instance or VM/bare metal machine that is hosting the container. Do you want to take a hack at that?
Sure. Yeah. I think my MacBook froze, so I'm rebooting that now. So. Sorry, I wasn't actually listening completely to the full question, so why don't you just say that again, and then I'll... Yeah,
sure. He was asking if there are any best practices for managing instance-level configuration as it relates to immutable deployment. And this assumption was that some configuration data will vary across a particular container instance or, bare metal or VM machine that is hosting the actual container. So is there some way to manage sort of instance-level configuration when you're provisioning hosts, I think, is the question.
Yeah, so I think the question is about the host, not the container. So from a host perspective, basically what we care about from a Rancher perspective is that a Docker daemon is up and running. So how you configure the host, you're still you can do your standard approach with configuration management, putting things into like your user data, those approaches. We don't. If you go with, let's say, like Rancher OS, where it's like more minimalistic, then you can base everything off the cloud config. But if you have like a more traditional approach like Chef and Puppet, that works too. So we don't, from a Rancher perspective, it doesn't really matter that much to us, I guess.
Okay. Another question that came in was, was it possible to use Bitbucket as authentication server with Rancher, like you were just setting up GitHub? That was from Paul Kasparek.
Yeah, so we don't have Bitbucket right now, but that's been basically the priority of requests have been GitHub first, and then 80 LDAP is next, and then Bitbucket will be after that. So it's currently on the roadmap.
Great.
Okay.
All right.
I'm almost back in the webinar.
That's all right. What do you just eventually we'll get there. one of the things that someone else was asking was Diogo Monteiro. He asked how you can apply some capacity management rules to a Docker host through Rancher. For example, if his Docker host only has 8 gigs of RAM and he's deploying multiple containers, each one using 2 gigs of RAM, how can he make sure he doesn't over-provision the host? From the point of view of a cloud provider, where it gives users self-provisioning capability. So, any thoughts on kind of controlling over-provisioning of hosts while you wait for your machine to boot?
Yeah. So for over-provisioning of hosts, so basically Docker provides the ability to limit the amount of resources given to a container, and then you can do scheduling based off of that. Right now in Rancher we don't have resource-based scheduling, but we're looking to we're basically looking to better integrate with Swarm and leverage a lot of the scheduling capabilities that they've built, and they do have resource-based scheduling. In fact, it is possible to use Swarm with Rancher today in some capacity, but we're looking at having better integration there. Okay, so I should be back up here. Okay, so show my screen. Right, can you see my screen again?
I can. You're back live. I switched you over to the other person. Okay.
All right.
So you're setting up at control.
Yeah. Wow. And Firefox did a good job just restoring right where I was. Okay. So right. So we are going to update. So right where I was. What's that? So we're creating the GitHub configuration. Let's see. Okay. Let me just kind of start with register a new application again. Okay. So we had done Rancher demo. We just need the URL here. Okay. And then once we say register application, then, well, I think I've gotten past this one before, but that's all right. So we just need this client ID and client secret. So once we just paste these in here. So client ID, and go back over here, client secret. Click authenticate, and this will basically have to authorize to the OAuth authorization flows as well. So okay, so now we have GitHub set up. You can see, you can kind of tell it's GitHub because it's got my little GitHub avatar up there. Okay, so now that we have GitHub set up, so basically what we want to do is we want to create some environments. This way we can kind of separate the resources. So we're just going to create like a dev and a production environment. So if I click up here, this is where my environments are. And I can click manage environment here, and by default we create one, which is called default. And I'm just going to go and rename this to dev. So we'll just call that dev. And here we can just add in anyone. So whatever teams, organizations, or people in GitHub, you can just add them here. So right here, I'll just add, so this is development. I'm going to open it up to, all of Rancher. Anyone in the Rancher organization is allowed to use it, and they're a member. If I put them to owner, basically the difference between a member and an owner means an owner can then also authorize other people to use that environment. So right now we'll just say, okay, everyone is a member, and then maybe I have a team I've set up. Let's see, called ops. So maybe I have an ops team, and I'm going to put them as an owner, so the ops guys can go and add other people or do whatever they want. So we've updated the dev environment, but let's create a production environment too. So we'll just call this one prod.
Before you jump past that, the environment, there was a question about the GitHub piece I thought was a good one, because it kind of addressed what you were talking earlier. Bill highly asked, if you point Rancher to GitHub Enterprise, does it utilize the authentication type that is configured for GitHub Enterprise, for example, SAML, AD, or LDAP, etc.? So can you get the transitive properties of GitHub Enterprise to handle user management that way?
Yeah. Basically, yes. So basically, what we do is we just do an OAuth authentication to GitHub, and then however GitHub manages it, that's up to them. So yes, it will work in kind of a transitive nature that if you have AD set up with GitHub Enterprise, then you'll get AD today. That's actually a good point. I never really thought about that.
One of the other, just to be clear, so there was a question Michael was asking. He kind of missed how we got to this point already. So just to be clear, what you've deployed so far is Rancher beta. You've used the open source Rancher build to deploy Rancher/agent on a host running in EC2. Is that right?
Oh yeah. So these VMs are these are actually running in Google right now, and I'll be spinning up machines across Amazon, maybe DigitalOcean too.
Okay, so you pre-provisioned a couple hosts on Google, and you're running Rancher/server on there and exposing it out. That's where we're at, and now you're connecting it to GitHub, and we're just about to set up Docker Hub, right?
Yep. So I just basically this one command I hear kind of in the middle. That's what I've ran so far, and I ran that on a virtual machine in Google. So sorry if I wasn't clear about that.
Okay, great. Thanks.
Okay, so yeah, so the production environment, we're going to set this up, and we'll call this one so this one, but basically for the production, we're just going to authorize just like the ops team. Like they're the only ones who are allowed to actually touch production. So the whole company can access dev, but production is locked down to just certain people. Okay. So now you can see on the top here, I have either dev or production. So once I'm in, so we'll start with our dev environment. We need to add some hosts. So if I click on the Add Host button here, we have a couple options. You can just easily deploy on a cloud through our Docker machine integration. So you have like DigitalOcean, Amazon. We'll be adding more of these. Or the kind of the most popular approach is that you just copy and paste this script, and you can run it on any host. So most of the time, I mean, the vast majority of the time within like a larger organization, there is some other process or team or something like that who will manage like spinning up resources and allocating the groups and stuff like that. And so if you have your own process, you can just basically, you just need to include this one script somewhere, that's just this one line, and then it will register your server. So what we'll do,
Darren, just a real quick question. Is there any, this is a question that came in from Jed Montgomery. He asked if there's any issue with running a Rancher server and agent on the same machine. So if you just have one machine and you're trying to set this up in a small scale, any issue with that? I know he was saying at some point there was an issue.
Yeah, that will work. The problem you run into sometimes is that when we try to discover the IP addresses and stuff to set up the networking and things like that, we picked the wrong IP. So we have some special instructions if you want to run on the same host that you kind of have to be careful to which IPs you use in the agent. For most multi-node deployments, we can properly detect the communication paths, but because of the local host matrix, it's a little weird. But it still works. It's just sometimes it might take a little bit more setup. Okay. Yeah, I have to kind of open up all these terminal windows I had here before. Okay, so what I'm going to do is I'm just going to log into an instance that I have pre-created on GCE, and I'm just going to run the script, and you can see how we can register a host. And then additionally, I'll go into Amazon and spin up some instances through our UI. Instances. Okay, so here we go. So we just need to copy this. So once I copy, run that command, I can tail the Rancher agent. Oops. There you go. Okay, so you can see the Rancher agent is coming up now. It dynamically downloads some things. So the very first run of it, it might take 50 seconds. But as soon as this is registered, you'll see on this screen it should pop up. Let's see. Let's just give it a second here.
And Darren, Jacob was asking about, as this is coming up, he was asking about if there's any way to provision a rancher setup via scripting. Do you need to, in some kind of infrastructure as code approach? Anything you can add to that?
Right. Yeah, and so there definitely is. Like, I mean, everything, basically everything we have here is backed by an API. So you can see, the UI actually just runs as a pure client-side JavaScript application interacting with the API. So everything that you're doing, everything that I'm doing, you can do through the API. We make it pretty easy to discover how things work in the API. There's also a CLI for it. Yeah, so basically you can script this. So it's like that registration URL, basically you have to post to this thing called registration tokens, and then this is where you actually get that command. It comes from the API.
Great.
Okay, so
it looks like your first host is up.
Yeah, so that one registered. So I got one host there. So I also want to go. So I want to go to my production environment because the environments, the hosts are owned by the environment. So you can see when I'm in prod, I don't see that host. So they're completely separate between the two environments. If I go back here, so in dev I have that one that is created. Production is separate. So this one I'm going to spin these instances up on Amazon using our UI, and it's actually really simple to do. Oops, I'm going to move this bar. Let me just copy my access key and secret key. So basically, we interact with the Amazon API to just discover things, just make it really easy to set this up. So at this point, you have to create a security group. You can use like an existing one, or we'll create up a standard one for you. But I'm going to use a custom group that I've already created, which is just all open, just completely open. I mean, from the way that we do Rancher, everything's private by default. It's running on a private network. You can only expose the ports that you want to. So it's actually a secure configuration to just keep everything open. Okay, and then so basically I want 3 of these, and then I'll just call these prod. So they'll get named prod 1 through prod 3. Let's go with a little bigger instance, a T2 small, and yeah, that's basically it. So this is going to go out to Amazon, and it'll set up these machines. So if this is deploying a virtual machine, it will take maybe 5 minutes or so. So we'll kind of come back to that, and we'll see those working. So the last thing that
go ahead. Sorry.
The last thing that I want to do here. Oh no, actually two steps is. First is we want to go and set up some registries. So this is basically you already have a registry. We don't manage the registry, but you want to add credentials such that when the user deploys to Rancher, it uses the right credentials. And so you can basically do this with any custom registry. So if you set up your own, through various different means, it should work. But then the popular ones like Quay, Docker Hub, and Quay, we just made it a little easier. So here I'm actually going to set up my real account here. And then I just need my Docker Hub password. Oops. Okay. All right. So that's basically going to save that credential into Rancher. So when we deploy or have to pull an image, we can use that credential. The other thing that you're going to want to set up, because we're going to do some automation with the CI, is we want to be able to interact with the Rancher API, use the Docker Compose syntax to deploy things. So we're going to set up an API key here. So we just need to go add an API key. So I'm going to copy this and save it in this environment here. Just a second. Okay. See. Okay. So I'm going to save this for later purpose. Basically, what you need in order to talk to the Rancher API is you need the URL. Like these are like the standard environment variables that we set up. So we have the URL, and then we have the access key, which we have there. And then the secret key. Okay. Okay. So now, at this point, basically, we've kind of set up all of the all the accounts. We've got some resources. We've set them up in different groups, and so that kind of concludes this phase of the demo. And then, so I'll kind of hand it back to Shannon.
Great. Thanks, Darren. And hopefully that gives you guys an idea of how the core platform gets set up. I'm going to become the presenter again, and hopefully you all can see my screen. All right. So the next piece we want to address after this is how to actually do builds and testing. Because I think one of the most one of the most obvious benefits of Docker that a lot of companies are already starting to realize is the impact it can have on build processes, test environments, and really automating that portion of the pipeline. So if what the next piece we're going to implement is Jenkins. And with Jenkins, we really we have a couple of requirements that we want for our build and sort of test system. One, obviously it needs to be triggered by GitHub. So as you push new code to GitHub, it should be able to detect that that's happened and listen to that trigger and actually pull the code to then effectively call Rancher and deploy slaves. So Rancher is going to it's actually going to go through the process of automatically creating the Docker machine or Docker slaves for Jenkins. And so that's we're going to show how to set up Jenkins and then have Jenkins call out and create effectively slaves to do the build process on. And then once those are in place, we'll use those to actually run the builds to build in those containers and then push eventually images to Docker Hub. So we're going to be going from the code uploaded to GitHub through to builds being done on our hosts to pushing images into Docker Hub that we'll be able to then pull from to once they're there, deploy using a compose template that we're creating to actually set up and deploy out those environments. So we'll be packaging that compose up in GitHub, sending it through to Jenkins, then sending it to Rancher to go and set up environments. Maybe multiple environments per build to run different types of test environments on. So that's really the next big test is can we take from pushing into GitHub all the way through to testing and building and testing our environments. So that's a piece we're going to cover now. Darren, you set up for that, and I'll pass it back to you.
Okay. Yeah, just setting up a couple things since I lost my machine earlier. I'm trying to log back into a couple systems so I can.
No problem.
Right. So what we're going to do now is screen here. Okay. So you should be able to. Okay. So the first step of what we're going to do is we're just going to deploy Jenkins. So we're going to do like a master slave environment. So we deploy the master, and then the slaves, will run on different hosts, and then we can kind of scale up and down the number of slaves that we have. So hopefully this goes well. Manage that. Have my machine freeze once. Okay. So what we're going to do is deploying. Okay. So if I go back to my Jenkins machine here, we're going to deploy this Docker Compose file. Okay, so we're going to use this Docker Compose, and we're going to deploy it onto Rancher. So these are actually some pretty standard images that I found. They're really quite good. It was called C. Sanchez Jenkins Swarm. This guy's done a really good job of packaging up Jenkins in a Docker image. And then I just basically created some Docker builds. I could create the master to kind of pull in the plugins and things that I need, to be able to do. So I just can Git and some other things to set up CI and everything. So I just created two Docker images here, a master and a slave. You can see the slave one here. slave, I need Rancher Compose in my build environment, and then I also need Docker so that we can actually kick off Docker builds. So these two images that you'll see in the Docker, in my Docker Compose, they say I built the cloud, but basically someone else already did all the hard work. I just customized them. So what we're going to do is we want to deploy this, and this should set up our Jenkins environment. So as I did in the previous step, I created the access keys, or API key. So I'm just going to source that into my environment, so I have my environment set up properly. And then I should just be able to say Rancher Compose up. And when this happens, it should create a new project in here and start deploying the application. So creating. Right. So if we go back here, click on projects, you can see basically it created this project called Jenkins. It's deploying the master right now, the master container, and then since this is the very first deployment, I think it had to set up the networking, so it'll take a little longer. But I want to show. Let me go back to some this Docker Compose file and oops. Let me just do a Control-C so I can go back to the Compose file, and let me show you some things that we've done with the scheduling here. Because when you look at this service, you can see, okay, we launched the service, but the slaves, there's actually no containers yet, and it's degraded. The reason for that is basically what we've done is for the slave is we set up some custom scheduling rules here. And we said, make this a global scheduling. Global scheduling means put one of these on every single host, but we put an additional criteria on here of saying, okay, the host label has to have Jenkins slave. So you can see here, if I go to my infrastructure, I just have one host, and if I go and I look at the tags or the labels, basically there's no labels on this. So I can go and add. Wait a second. Okay.
This is Darren. What you've provisioned just a second ago, you're actually using Rancher's CLI, correct?
Oh yeah. So that was the Rancher.
I don't think you actually made that clear. So yeah,
oh, shoot. Okay.
The piece that you're using to actually deploy all this is Rancher Compose. So go ahead. Maybe you can talk about that.
Right. So yeah, let me talk about it a little bit to explain how that works. So basically, what we've done is we have our own. So we're using a Docker Compose syntax, but we've implemented re-implemented the Docker Compose client that interacts with Rancher. So it acts and behaves pretty closely to the real Docker Compose. We're actually working pretty hard to contribute back a lot of the code that we did, because for a lot of technical reasons we had to write this in Go. If anyone realizes Docker Compose is actually written in Python, so we basically created our own, but it acts and behaves a lot like the regular Docker Compose. So when I did up, I ran Rancher Compose up. So this is our own tool here. So I can say like Rancher Compose, Rancher Compose help. So so basically like up, logs, restart, stop, down, scale. A lot of the things that you would see with Docker Compose. Okay, so going back to the getting the Jenkins slave up and running here. So this host here does not have any labels, so it won't deploy the slave here. So I need to launch a host. I can either add the labels to this host, or I can just go and launch another one. And so this is where it actually gets really interesting from like an auto-scaling perspective. Like if you hooked up like an Amazon auto-scaling group, or maybe you have some other ways to just deploy new VMs and things like that. Is in this screen here. Oops, sorry, Jenkins slave. So if I do this custom approach, like I can do the same thing through any other provider, add labels when I deploy the machine, but I'm going to show you here this custom. Basically, it's just adding to the command, what are the labels that should be on this host when it comes up. So if I go and let me log in. Let's see which host this is. Nope, that's not the one I want. Okay. Let me just list these compute instances of this.
There's a question that came in while you were doing this, Darren, from Rasesh. She was asking if all of the things that we're showing can be done through the Rancher UI as well. And from that perspective, most of the things can be done through the Rancher UI. All things can be done through the API. So the API is sort of the master of everything that can be done. The CLI is specifically useful for deploying things like compose templates, though. So, right now, if you have a fleet of compose templates you want to deploy, you want to use the CLI to deploy those. Rancher's UI, you can build your own compose templates within the CLI and deploy them, but we haven't yet added the ability to sort of upload a CLI or call a remote, compose file to do that. So that could be a little unclear, Rasesh. It's something that we'll be finishing up during the beta process. So over the next month or two, you'll see that appear that you'll be able to sort of arbitrarily launch compose files from the UI as well. Anyway, go ahead, Darren. Just answering that question.
Yeah. So everything lands in the API first, and then it kind of moves into the UI and stuff. So what we're going to do here is, this is another virtual machine that I've spun up on Google. And so I'm just going to run this command. So again, basically when it launches this host, it's just assign this label of Jenkins slave. So let me run that command. I can just tail this to make sure everything's going good. Rancher agent. There you go. Okay. So let me go back to the host screen here. So when this comes up, so basically we should have a host come up. It should have the label, and then you should see that the Jenkins slave should get automatically deployed to it. Let's see. So it's almost there. Yeah, it looks like it'll take just about 10 more seconds. Okay, there you go. So yeah, so it has the label Jenkins slave, and you can see we already, so we see that it had that label on there, and we deployed the slave. So if I want to add more slaves, basically I just add more virtual machines with this tag, and then you can scale up the number of slaves that you have. Okay, so if
as you were saying earlier, you could also, when you add hosts through machines, you can apply the slaves, the tags as well, using Amazon or any of the machine integrations.
Yeah, so exactly. So down here, like this is, if I'm going to, like, let's say DigitalOcean here, I can just say, okay, we'll add these labels. So it'll automatically come up. Okay, so basically now we've got, we should have Jenkins running now. Let me see. You can see the master is running on this host. I believe it's on port 8080. Let me go back. Yeah, it should be on port 8080, that host. I type something wrong. Oh, okay. I don't know. Maybe I checked the URL wrong or something. Okay, so you see we have that up. Not totally sure where my slave is. Let me just restart the slave. See if it like failed to register or something. I don't know. Yeah, here. Okay, yeah, I'm not quite sure what happened there. But, so basically, maybe this is the most robust.
So now you've got the slave. You've got the slave and the master both showing up in Jenkins. This is actually your slave node.
Yeah, so I have my slave running there, and so this is basically the way this worked when I deployed it was, if I look at this Docker Compose, you can see I linked the master as the DNS name Jenkins, and so when this comes up, well, I think by default it looks for the host named Jenkins. So that's how it was actually able to discover the master. It's just through our service discovery. Okay. So that's a basic. So we have a Jenkins deployment running. We can add more nodes. We wanted to have more Jenkins slaves. So now the next thing is basically to get a build running. So there's various different ways you can manage. Jenkins you can do just like a million things with, and there's various ways to manage kind of the Jenkins state and everything. We're going to kind of cheat here and just copy in over a build a build, a config XML that I already created. So I'm just going to go directly onto the host and just copy this over. Let's see, we should have it here. So what I'm doing is I'm just looking up where the Jenkins home directory is. I can just copy in this file. So if anyone very familiar with Jenkins, this should look familiar. Basically, I'm just going to create. We're going to create a Let's Chat job, and then in the Let's Chat, we're going to copy over my config XML, which I already have basically set up for the job. Okay, so I just copied that. Let me go back to my Jenkins and just tell it to reload.
So Jenkins, you've got Jenkins now running. It's running, the master and one slave. You've connected it. You've created a new Let's Chat environment that you're going to be using to build out the Let's Chat application.
Yeah. Okay, so now that I have this job, so I have a Jenkins job set up, and basically what this is going to do is build the application and then automatically deploy it to Rancher so that I can do some testing of the application. So before I can do this, I have to, since Jenkins is going to interact with Rancher and Docker Hub, I need to set up some credentials and things on this environment, or on the build itself. So what we just need to do is just go and add some credentials. Like I can show you the build configuration. It's pretty straightforward. Basically, we're going to hit this Git repo here on GitHub. Right now, I just have it set up to just do polling. So SCM polling, so just every minute. But for the demo, we'll probably just click build just to make it happen immediately. I have some passwords set up. So basically, the Docker Hub password here, I need to actually put in my real password. So that it can pull and push the images. So let me put that in there. And then this information here needs to be what I had copied, the API keys that I had set up. And that was this information. Let me just copy that and paste it in here.
Well, you got an extra R at the top.
Okay. Right. Okay. So now with those two things, I should be able to save, and then hopefully the build will go well. If not, we'll reconfigure it. We'll see what's wrong. Okay. So this is launching a build on one of the slaves. If I go to console output, so I should see. Okay. So the first thing it's doing is doing the git clone. It's doing. Let's see. Oh, wow, that went quick. So basically, it did the Docker. This is the Docker build, because what this is doing is it clones the source. It does a Docker build to build the application, and now it's pushing the image out to Docker Hub under the name I build the cloud Let's Chat 1. That's the build number, build 1. So this is going. It's pushing this out there, and then so the very last step is going to be that it will actually deploy the application on Rancher. So you can see the last step here. So it's creating an environment. It's creating a service called Mongo, so MongoDB, and then it's also creating the app. So if we go back over to Rancher, we look on services. You can see, okay, yeah, this app is actually, it's coming up here. Let's see why this guy's not happy. So we can check out the logs. Oh no. Shoot. My virtual machine I'm using here does not actually have enough free disk space. Let's see, where did that deploy? Maybe I can just clean something up really quickly.
Actually, there was an earlier question I was hoping to get to it. It was someone had actually asked about, once you deploy um, a VM, is there any way to update it or change it? And like say you want to go and add more capacity once you use machine to create something. Is there any way to change that host once it's actually created? I think it was Frederic Prior who asked that question. So the answer is no, really. I think once you've deployed it, you have to go into the cloud provider to go and modify it from within Rancher. You can't go and change the the provisioned image.
Yeah, so let's see. So it doesn't seem to like this one. So let's just do this. Let's just hope that the other machine has more disk space. So what we're going to do is we're going to make this machine here inactive, and then we'll delete these, and then it should schedule them. It should schedule it onto the other host. So let me go back over here. Let me actually just delete the Mongo app because we know it's not going to start up. And then hopefully it should schedule it over here on this other one. Just give it a second.
So when you tried to deploy the original MongoDB, it was the host that it put it on didn't have there wasn't enough capacity left there,
Yeah.
so it couldn't start. So now you're putting it on the other host, and it is starting.
Okay. Oh yeah. So it looks like that did start up on that one. This one is running here. Let me see. I can't remember what port this is. Oh, just on port 80. Okay. So if everything worked right there, basically we should be able to hit that. Yeah. Okay. Wow. Okay. It actually came up. Okay. So yep, some live troubleshooting. But so you can see some of the scheduling stuff. Like we ran out of disk space, so that wasn't launching. So we was able to just deactivate that. We scheduled it over there, and it came up on the other host. But the app is this app is still running. Like the application is still running on that host. When you set things to inactive, basically what that means is like just don't schedule new things to it. It's kind of like putting a host into like a maintenance mode type thing, so that I can still actually like start and stop these applications. They're still running there, but scheduling won't add anything new there. Okay, that was fun.
Yeah, there was a I think Oliver Robert had a suggestion that, or no, it was Diogo Montiera said if you set the -small files flag when running Mongo inside containers, it removes that problem. So just a hint for everyone else.
Yeah, so I did not exactly. Yeah. Okay, so basically, that showed kind of the whole flow of deploying the application. So we set up Jenkins. Jenkins itself is running a Rancher. Then we use Jenkins to actually do a build, which then deployed it to Rancher. And this setup, like the style of how we're doing this is basically every build would just get deployed as like a new application. So what we can do now if we want is we can just go and change something, do a git push, launch another build, and then it'll deploy like a new version of the application. So let me actually go to where I have the source. Let's check. Okay. And we'll change the footer here. I am not a web person, so I don't know a lot about what to change here, but we can put some text in here. Okay, so Rancher demo. So we'll just do that. Add that change. Call it change. Git push. Or just push to master, which is terrible. Okay. Okay, so we pushed that. Within a minute, it should detect and then build, but to be impatient, we'll just do it. I mean, Jenkins, there's like a million ways you can do this. You can have it like hook up to PRs or automatically, like when a Git gets Git hooks to automatically kick off builds immediately. But we're just going to manually do things right now. Okay, so this, we go look at the console output again. So, right, so it looks like it's up. It already, the build mostly already happened. It's just doing the uploading the image again. So when this runs, basically we should get a new application, like a completely new application, a new instance of Mongo and the Node.js app running on Rancher. Maybe we'll run out of disk space and Mongo won't start, but you'll see the basic idea.
Because I know there's lots of questions and things filing in. I'll try to jump in and grab them, but we're we're trying to get through a little bit of this before we kind of, I know we're already into an hour. So feel free to keep asking. We will get to your questions and comments as fast as we can.
And this, for the most part, wraps up like most of this demo before we get on to the next one. But so you can see, okay, so let's chat 2. This is coming up. It's launching it, but let's see, that it's stopped, so that's not really a good indication. Let's see if this 2. Okay, we'll just ignore that error. Okay. Oh, it says action not available. Okay. I connected the logs, I think it was probably stopping or something. Okay, so that one's not launching because I bet you it's going to be the exact same. Oops, that was not the link that I clicked. View logs. Yeah, okay, so exact same error. So unfortunately, I did not set up enough disk space or whatever. But hopefully
the main idea is the same. You're basically provisioning out these different, as builds happen, assuming you have a big enough build farm, these will get deployed out there. You'll be able to test the different builds and run your test scripts. Now, we didn't show really running the test scripts from Jenkins, but I think that would be kind of an obvious,
Yeah,
next
so
step.
I can show you. So here, let me just tell this thing to stop so that this for this, basically, I can show you kind of the script that we were using in Jenkins. It's really straightforward. Basically, we're just doing a Docker build. Then we do a login and push. There's actually much better ways to manage the credentials than doing a login and script. But then we do a push, and then we're doing a Rancher compose. So the last step, if you wanted to do testing, was basically once compose, like once this is up and running, then here start running your tests. So you run your tests against the new environment, and then you can do automated testing. Okay.
All right, excellent. So we've basically shown, deploying Jenkins, getting Jenkins set up to deploy slaves. We didn't really show auto-scaling of the slaves. That's something that I know we were talking about trying to squeeze into the demo, but we didn't really have time. We didn't think to go into it. But you can actually auto-scale the deployment of slaves as you need more of these using something like an auto-scaling group in Amazon, for instance, if you wanted to. There's a couple of different approaches that you might want to take. But really the idea here for this Docker service is, once you've actually got this, kind of laid down, Docker Hub, GitHub, Jenkins, Rancher, for an environment, things like, literally from Git push to test should all be happening very quickly on the back end. You'll be able to see these things, like Darren's showing, very quickly pull the logs, see what's causing the errors, get notifications when something fails to build correctly. So there's a lot of what we're really trying to get here is a fully automated experience. So I'm gonna take back control, Darren, unless there's anything else you want to show.
No.
Okay. Let me take back presentation. Okay, and someone had asked where they can find the recordings of these meetups. If you come to our website, this is rancher.com, you can pull up just the events page under our About section. You'll see events. And we have all the recordings of our past meetups. They're all kept here. So feel free to peruse. This will show up there eventually. All right, so stage 3. We've taken us an hour. We've hit crashing websites and full disks, but we are now at a point where we've got the actual system up and running. We've got Docker Hub going. We've got our GitHub working, Jenkins working. We've got some hosts deployed, and we've got both a development and a production environment created. But everything so far has been done in our development environment. Now we want to start moving this stuff out to production. So at this point, we're really we're going to use the Docker Compose format to describe the application we want to run. And we're basically going to use Rancher, the Rancher CLI. Darren's going to show you how to pull that. But now, instead of a test setup where we don't really care where everything runs, we're going to have a more, more specific implementation where we want to set up a load balancer. We want to maybe have some policy about, how these containers get deployed and where they run. And then once once we get through setting up the actual production environment that we're going to use, that will be our live environment where we've set up some level of isolation for the different containers, we want to go through, we'll look at how to monitor that. So we're going to use another Docker Compose file to deploy Prometheus, the monitoring agent I talked about before. So we'll have a Docker Compose file that it's very similar to what we did with Jenkins, where we deployed the slaves and we said, deploy these on all the different hosts. We'll do the same thing now with Prometheus, and we'll set up a monitoring to do some production monitoring of the containers in this deployment. This could obviously be Sysdig or Datadog or any other good container monitoring tool that you might want to use. Just like Jenkins could be, Circle CI, or it could be Shippable, or it could be, Drone, or many other things. So we're going to go through all that and set this up. And the idea here is to show you how you can deploy these sort of standardized processes, like a Jenkins environment, like a Prometheus environment, like an ELK environment that you want to just set up and have almost available as library services that can be deployed for any project. So as a new project gets spun up, you say, oh, we need Jenkins for this. We're going to, as we move to production, we're going to want to use our Prometheus environment. We're going to want to use, our logging environment. You'll have these different sets of templates to deploy. And it's one of the things we're looking at as we look in the roadmap down, in Rancher, how to manage these sort of stacks and these different, services that get deployed lots of different times. Is there a better way to manage a service catalog in a Docker world than maybe what we've done in the past? So lots of different cool opportunities to augment that. So that's sort of the last bit we want to try and show you now, is to move this from from the dev environment to we're happy with the build, we want to roll it out in production, we want to actually put it behind a load balancer and monitor it, and I don't know if we have time, we could look at upgrade or something like that as things go. All right, Darren, you ready? When we pass it back to you, we'll hit this last section. Okay, you have control.
All right. Show my screen. Okay, so what I'm doing, so basically what we're going to do is we're going to deploy this application in production now, our production environment. I was just adding those Amazon hosts. I'll just close this screen here. So those Amazon hosts had registered, and I was just adding some labels to them, so that when we deploy Prometheus, basically the monitoring agent will get deployed on them. Browser's having issues. Okay, so what we're going to do, if we go back to, shoot, I think the browser's free. Okay, give me just a second.
There was a question that came up while I was talking, I think, that I'll try and address now. Marco Uskovic had asked, how can we link Mongo from, say, Let's Chat 1 into Let's Chat 2 instead of deploying a new Mongo container? It's part of an upgrade where you're actually able to upgrade individual services. So when you look inside one of these service stacks, you can upgrade the whole service, or you can simply upgrade an individual component, either using the UI or using Docker Compose. So there's, Docker Compose gives us a lot of flexibility with how we're doing things. We're actually working, and we're about to release in the next week or so some rolling upgrade type of approach where, let's say you have 10 Let's Chat nodes, and you want to upgrade those 10, from build 1 to build 2. You may want to have them come up, build 2 sort of come up, and as they come up, get put into the pool, and then slowly start taking things down. So you'll be able to do some cool rolling upgrade type of work where the containers are not sort of just switched over en masse, but rather sort of slowly done. I mean, I know a lot of people doing sort of A/B type of things where they'll spin up all of build 2 and then maybe start adding them into the load balancer. And for some period, they'll run everything behind the load balancer, maybe until all the sessions are finished on some of the hosts. Say the build one host, and then they'll start taking those down. So there's a lot of complex upgrade processes that people are doing, and you certainly can upgrade individual services instead of deploying an entirely new stack. Most likely that's what you'll do. Most of the time you won't upgrade both the Mongo environment and the Let's Chat environment. So I hope that answers your question, Marco.
Okay, so I'm actually going to show some of the things that you just described there. So we're going to deploy the Let's Chat application. Now, if I go back to Jenkins, I had done 2 builds. There was like version 1, then version 2. The builds, when they're done the way I'd set it up, is it actually produces, view it here, produces a Docker Compose file. So we're just going to use, we'll start with this Compose file of deploying this application. If I go back to, let me go where I had this, Jenkins prod. Now I had set up some API keys. So these are the API keys that I'm using for my production environment. So let me just source that into here. So basically when I use Rancher Compose, it's going to talk to the prod environment. So you have API keys that are separate per environment. So let me see what let me just get rid of this Docker Compose that I already have in this folder. Okay, so I'm going to create this new Docker Compose file based off of the one. Okay, so this is the build produced this, and this is basically the image that was produced, which was version 1. It was like build number 1. So this is just a very basic Docker Compose file to get this application up and running. But in production, we're going to want like a little bit more of a scalable setup. So what we can do is we can add a load balancer here, and this is going to then use the Rancher load balancing capabilities. You need to specify the special image, which is load balancer service, and then we say, okay, what ports do we want this load balancer to listen on? So we're going to say, okay, we want this to listen on port 80, but then we're going to forward traffic to 8080. As you can see, this service here is actually listening on 8080 internally. So now we set up how it's going to forward the traffic, and then we need to make sure that we link this to app. So now that it's linked, we can actually, this is basically the target that we're going to be load balancing. And since we have this load balancer exposed on port 80, we don't actually need to expose any ports publicly. So I can just delete that from the application. So the traffic between the load balancer to the app will all stay private. Okay,
is there
so
you didn't do the 522 one as well? Is that I know you noticed that there's a link for 522 in there. I think that's necessary because it's a chat application between the things.
Oh yeah, maybe it does also 522. Oops. Okay, I'll do that. Okay, thanks. Okay, so now basically I'm going to run my Rancher Compose up, and it's going to use this Docker Compose file, and it should deploy to the production environment. So, so we can see hopefully this one goes better in terms of disk space. These are brand new machines from Amazon, so they should have free disk space. Okay, so we can see the very first deployment. So it's deploying Mongo here, setting up the network. Basically, this is our network agent, which provides our overlay networking that has to be deployed the very first time. So that, so this is a clean machine.
And both of these are getting pulled down from Docker Hub, right? So they're actually pulling from the private Docker Hub environment. So it'll take a second to pull the image down to EC2 or wherever this is getting hosted, right?
Yeah, exactly. Yeah. And you can kind of watch the status of this too. Like you'll see, okay, it's downloading, it's extracting the images. So it should come up in just a second here. Okay, so while this is starting up, basically the next step of what we're going to do. Let me let's do Control-C on that. So basically what we're going to do is now that we have the Docker compose, so we have a load balancer pointing to the app here, what we can do is say rancher compose scale. So we can say scale app to. So this is exactly the same as the way Docker compose works too. So basically you just say scale, what service, and then you want it to scale up. So since the load balancer here is pointed to the app, that means that as we scale this up, it's automatically going to add to the load balancer. Okay, goodness, those are downloading slow. So that will scale up to 2. Okay, so since this is all, still downloading Mongo. Okay, well we can just kind of watch it here. Let's see, no, okay, so the app's actually coming up now. Once the app is started, then basically it'll end up with the load balancer. So since those are taking a little bit to deploy, I can talk about Prometheus. So what we'll actually do is we'll launch Prometheus too. And so Prometheus is a monitoring system. And so besides just running like your application, so I have basically a Node.js app here, talking to MongoDB. In production, you're also going to want various monitoring tools and things like that. And so with the scheduling policies and things like that in Rancher, it becomes really easy to manage those things with Rancher too. Specifically the global scheduling that I talked about before. So if I go into this Prometheus folder, you can see we have this Docker compose file here. And what this is going to do is it's going to set up this is the Prometheus server itself, so it runs on port 9090. And then we set up this other service called monitoring. And this basically, oops, oh, sorry, I thought the phone dropped. This has a global scheduling rule here, and it basically is going to just deploy this to monitor true. So what this service is it's the agent, the monitoring agent that gets deployed on every single box. And this is the Prometheus server, which then links to the monitoring agent. So the server is able to discover all of the agents and pull those in. So I can bring this one up so we can launch this. We can launch this service while those other ones are launching too. Sorry, Rancher compose up. I'll just do a -D so that it goes in the background.
So now your Prometheus agents are all spinning up. You can see them there spinning up on each.
Yeah. Yeah, so you can see, so basically the agents are launching first. So that's the Prometheus agents going there. I mean, I can go over here to the services view and you'll get a little better view of how this is working. So this is my application. This service down here is Prometheus. So you can see basically it's launching all of the monitoring agents right now. So it's pretty much waiting for those to come up.
We didn't really talk about the networking component here, but basically all of these are, you saw the networking agent spinning up at the beginning. This is all sitting on the Rancher, private network that gets established between the containers. So, these monitoring agents, they can even be on different clouds. I mean, we're showing them here all in EC2, but you could throw up, a monitoring node on DigitalOcean and one on a bare metal server, and they're all going to be able to talk back to that monitoring master once that comes up. Same with Jenkins for that matter, right? The Jenkins slaves could be really anywhere as long as they're part of the same, as long as the master and the slaves are inside of Rancher and the network, correct?
Mm-hmm. Yeah, and that's so it actually makes it really nice when you're spinning up things like when you're spinning up like when I do the Jenkins service, so like basically you can assume everything is on a private network. It's private, it's encrypted. So it makes it easy to, kind of set up services and things like that.
While you're on the looking at different containers, there was a question that Jed Montgomery asked about the graphical monitoring of a container and whether it would work with the network proxy. Do you know if that works? Yes, it does.
We've actually in the beta we've changed this some of the way the network communication paths work to make this really easy. So basically the way it used to work was the web browser would connect directly to the nodes, and we've changed that such that the nodes that are running your Docker containers actually connect back into the Rancher server. So all that's required from a node, like a firewalling perspective and things like that, is that it has to make an outbound connection to the Rancher server. And then when we want to talk to the node to get like the graphs and stuff like that, we now talk to the Rancher server and then multiplex the connection back to the host. And so we do this kind of like reverse tunneling, and this helps us to address a lot of like firewalling issues, things like that people ran into with Rancher.
Cool. Thanks.
Okay.
Looks like you got everything up.
Yeah. So basically, all this came up. We can look at Prometheus here. Let me go back to the kind of infrastructure view so I can see where these. So basically, so we're running, these are the monitoring agents, and then this one here is the actual Prometheus server. So we should be able to oops, that did not copy, sorry. Copy. 9090, right, okay, so you can see the Prometheus basically, so this came up, you know, and you can see, okay, here you go, here's the target. So it discovered all of the agents. So if I was deploying a new host that has a new monitoring tag, then it'll discover the agents. And so this guy here will just automatically start collecting stats. And, you know, this is like you can do quite a bit with Prometheus. But so to show you, okay, this is like, you know, this is pulling in information from these nodes and monitoring some things.
Just real quickly, the version you're using of Rancher, a couple of people had asked this over the course of the thing. Is this 0.26 you're on?
This is actually 0.25, which is not the latest release. Yeah, because there's actually, you know, we've changed quite a bit. So there's a release coming out today that we'll see if it's today or tomorrow, that basically has host name and path-based routing and the load balancer and rolling upgrades. So I'll show you kind of how you can do manual rolling upgrades. So we've actually automated the whole process. That's coming out today. So there's quite a few features that we've actually added into Rancher since the version that I'm showing here.
Yeah, you probably have seen, if you're following along on GitHub, I think we're on RC4 right now of, you know, 26, so, or 20, release
20, I think it's 27. Yeah.
So.
Okay, so basically, so we have the Prometheus running. We've finally got this app up and running.
Yeah, just while we finish that conversation, there was a question about that. Sure. Just can you explain the tagging for Rancher on Docker Hub right now? Should people be pulling the RC releases or just, you know, colon?
Oh, no, okay. So if you see an RC, you know, that's like really bleeding edge. We used to basically what we do is we used to have two tags, like a latest and a beta tag. But what we found was like people were always still pulling like the beta one, and so like we would do a build, and before we even tested it, people would download it and start using it. So we started putting the RC on there, and basically the RC means that like, you know, we've created the build, but we're still testing it. There might be bugs, and you know, might be terrible things. So you know, if you really want bleeding edge, you can really see like the newest features that we're developing. But usually it takes us about like three days to a week to when we cut our RC to make it like the actual release. You know, go through like our whole testing process and stuff.
Great, thanks.
Oops, I ran the wrong thing. Just ran Docker Compose. Rancher Compose. Okay. Okay, so just want to see. Oh, okay, yeah. So I didn't actually. I killed the Rancher Compose before, so it didn't actually launch the load balancer. But we have the load balancer here running now. So if everything's good, this should, right, okay, so we have our Let's Chat application up and running. So basically when I go back to my services view, I can show you here. So we have a couple different ways you can view this. We can show a graph here. This second to load. Oh, shoot, just click away. I don't know. It took a little bit to load there for some reason. Okay, so you can see we have a load balancer that's pointing to an application, the app tier, and then that's pointing to Mongo. So once we have that up and running, so now, if we want, we can automatically scale this. So as I was saying before, we just do basically Rancher compose scale app 2.
I think I may have talked about this briefly, but a couple of people have asked, we're using the CLI a ton today to deploy compose environments. And, the kind of questions come up a couple of times, is there a way to do this in the UI or the API that, we could call to? So I don't know if you want to just address that one. Maybe explain how you can do this stuff.
Yeah, the vast majority of what I've been showing today you can actually do from the UI. I mean, the only thing is when the UI, you have to click around, fill in boxes, so it's a little slower. So we, for the demo, I've been doing a lot with the command line. But you can do, like I was just going to show you some of the scheduling policies you can do. Like this is all in the UI. You can do some advanced scheduling where you say, okay, automatically pick hosts, for different, I'll get back to this one because actually I want to specifically talk about it. But basically, most everything you can do from the UI. There's a couple functionality that's not possible.
I think the big piece that people are asking about, though, is not so much that, but rather, compose templates. Like I have a compose template. How can I launch that from the UI or the API? Or is the CLI really the only way to deploy compose right now, and is that going to change?
Right. So the only way to deploy a compose template right now is through the CLI. That will change. Like we'll add UI support for it.
You broke up there for a second, Darren. You said the only way to do it is through the CLI, right?
Yeah. So the only way to deploy a compose template is through the CLI, and we'll add the ability to do that through the UI for sure. There's actually, as I was kind of talking about before, is we're very actively trying to upstream a lot of the code and things that we've done to make this possible. So there's a lot of work going on around this area. And so it will end up being in the UI.
Yeah, so the big work to get this stuff, I mean, there's as we go through beta, one of the requirements to people who are asking about that was we're working to build in, approach where you can, from the UI, just, upload a compose file and deploy it directly. But right now, if you're deploying from compose instead of sort of building directly as services, you definitely want to use the CLI. Whereas if you just kind of, if you're okay with deploying it manually, you can deploy each service the way you would just add in the way Darren's showing here, where you would deploy services and then you can export it as compose quite easily. So hope that helps.
Yeah, you can very easily export it out to compose. But unfortunately, right now you cannot just take the compose and put it into the UI. But we'll definitely address that.
All right, so we've got it running. We've got both services running. You were going to scale it up before we stop.
Yeah.
Did you do that?
So we scaled it up. So basically, there's two of them running now. If I go back to my services view, right. So this is just that project. I can see I've got two of these running now, and so they're both behind the load balancer. Now, when you deploy a service like this, if I have, let's say I have 5 hosts, and I scale up 5 containers, I probably want them to go on 5 different hosts. And so you can put scheduling rules on the instances, like to have anti-affinity. And it's easier to show this from the UI how this works. Is basically when you define your service, you can go into the advanced options and go to scheduling, and you can pick all these various rules, and you can say, okay, the host, basically there's 2 terminologies, must and should. Must is like a hard constraint, should is a soft constraint. Like a soft constraint, we try our best, but if we can't meet that constraint, then we drop it. So you can say, okay, well it should, like this one, the host should, let's see, should not is a better one. Should not have a service with the name prod app. So basically what this is like, what this rule will do here is it says when I deploy a container, it shouldn't be on a host that has a container of this service, which is myself, which basically creates an anti-affinity rule, which will make sure that you don't run your like multiple containers on the same host, like you spread them out. And so there's various rules that you can do, scheduling rules, and basically these all get translated down into labels. So the labels, as I showed before here, I believe. Oh no, not that one. Let's look at the Jenkins one. So there are various labels like this. So we have documentation on what all the different various combinations are. But you can pretty much do host tagging, like affinity, anti-affinity, container tagging, and then there's a special one for global scheduling. Okay, so I want to show you kind of how you can orchestrate an upgrade. And as I was saying, in the release that's coming out soon, we've actually automated this. So there's like a specific procedure to just say, okay, do a rolling upgrade. But sometimes those things don't work exactly the way you want them to. So we wanted to make sure that we had basically all the primitives in place, such that if you wanted to do your upgrades and things a completely different way, then you can very easily script it and automate it and things. So let me show you how. So what I deployed here was my version 1 of the application. So if I look at this, so I have, okay. Sorry, so it's let's chat, and then 1. So what I can do is, I can now just, okay, let me deploy like version 2 of my application. And we're just going to call it app2. And we're going to use the let's chat 2 image. So now if I go and do a Rancher compose up on this, let me show this from the services that graph view. Help a little bit. Okay. Okay, so that's coming up. So basically what you can see here is, okay, we have a load balancer, it's hitting my app, this is the current live one, but now I've gone and I've deployed app 2. So I've gone and deployed this, so like I have this one container running, it's actually starting right now because it's pulling the image. But if I go and I look at this one that's starting up, I think I have to wait for it to start first. I can show you. Basically, what you can do is once it's up and running, by default, when I look at my compose file, I didn't actually publish any ports. So it's all private right now. So like you can't actually access it from the internet. So if you wanted to just test it out, you could just go, okay, get this up. You can just go into here into the ports. Oh, sorry, click the edit. Edit here, and then I can just expose out a port. So I can just expose it out like on some random port or whatever. So I can hit this one container, test it, sanity test, everything that looks good. Maybe do some various tests. So basically, after you've done that, that looks good. You can then add it into the load balancer. So this is for if you want to do like a rolling upgrade. So right now my load balancer was only linked to app 1, but I'm now going to link it to app 2 also. So going back, let me bring up that services, the graph view. Okay. So when I go and now when I do a Rancher compose up, basically what it's going to do is it's now going to just edit the links on the load balancer and add both app and app 2 in there. So again, this is specifically if you want to do a rolling upgrade. So I now have 2 of these containers running and one of the new application running. So if this is just doing round robin load balancing, essentially this new app is taking 1/3 of the traffic. So now you can start scaling up. So I can say, okay, well now I want to scale up app 2 to 2, but I want to scale down the original app to 1. So now the majority of the traffic is now going to the new application. So you can say, okay, so this one is updating. It will take a little bit because it's going to pull the image. So it'll do the pull. So we have with the automated rolling upgrade that we'll be doing, we have you give like some logic of say, okay, how many of these containers do you want to run? What's like the batch size? What's the interval that you deploy in that? And so you can say like, if I had 100 containers running, then I want to deploy a new application, and then it will just slowly, based on the configuration of like launch, 2 new containers, and then bring down 2 old ones, then 2 new ones, and bring down old ones, and so it'll slowly roll out your application.
Very cool, man. So
Yeah.
as this upgrade rolls through, it'll kind of slowly switch from having 2 on that to 2 on the other, and as these things boot up and become active, it'll start to tear down the other deployment. Correct?
Yeah. And so you see this one, it actually became active now. So there's 2, and then it should go, and it will tear down the old one. Let me click on my now. The UI not might have updated. Yeah, it did actually. So app now just has 1, app 2 has 2, and then eventually you can go to the last step of go down to app 0, so that basically bring the application down to nothing.
Someone was asking, I think Rasesh was asking if you could, when you're diverting the traffic, can you divert the traffic based on a percentage of total traffic to things, or is it more just I know it's HA proxy that we're using for the load balancer, so is it more just limited by what HA proxy can do there?
Yeah, so basically the algorithms that we have in HA proxy, like so if it's round robin, then essentially the number determines the percentage, but it's based on new connections. So we don't have, I would say, like very kind of advanced routing for the upgrades. But basically, it's HA proxy, so whatever HA proxy can do, we can expose those capabilities.
Very cool. All right, I think you've got shown plenty. We're an hour and 40 minutes in. I know we've still got almost everyone, so I know a couple people had to leave, but it's great to see so many people sticking around and helping. The questions have been great. The participation has been awesome. I've literally probably got 15 to 20 questions that we wanted to get to. So before we get to all that, though, we'll probably just wrap up really quickly with everything we were going to show. Darren, is there anything else you wanted to show? I think we've hit everything, correct?
Yeah, I think that's pretty much everything. Yeah.
Awesome. Why don't I do this? I'll run through the last couple kind of close-up slides so people can take off and see what's coming, and then I'll jump into these questions. So we'll kind of answer the questions as we go through the rest of it. Thanks for that, Darren. Thanks for nothing like a demo where your laptop crashes in the middle of an online meetup. That is not fun. All right, so hopefully you guys can see my screen. So hopefully that was useful, and we gave you kind of an hour and a half to setting up something interesting. If you're interested in working with us closely and giving us feedback, and Rancher that we've been showing is in beta. It just started beta about 3 weeks ago. Not even, I think 3 weeks ago, just before DockerCon. So you can go to info.rancher.com/beta to join the beta. And there's a bunch of benefits you get for signing up to join the beta, like access to a beta support line, things like that. We also just implemented some new forums. So if you haven't visited rancher.com recently, I'm just pulling it up here. We have a couple of things that are new. We've did a big overhaul on our docs. So if you want to access Rancher docs, just rancher.docs.rancher.com. And you can get a lot of docs. These are all maintained in GitHub as well, so you can make pull requests on the docs if you want to help us keep them up to date. The other really good thing, especially I know a lot of people that attend our meetups are using Rancher pretty heavily. If you haven't seen, we switched from Google Groups, which we've been using in the past as a forums platform, to forums. We've created our own forums that are on forums.rancher.com, and we do our best to stay on top of these things and to answer questions, but I know a lot of other people are answering things in the community. So this just went live, I think, this week or maybe last week. So please give it a play with and use forums if you need to get some help. The only other thing, if you're not familiar, everything we're talking about, everything we do is open source. So you just hit our GitHub environment. You can go to github.com/rancher and get access to all of Rancher's code. We're always looking for people to make contributions. Give us a star if you like what we're doing, and get involved however it makes sense for you. finally, as I said, we're going to be handing out these T-shirts, so keep an eye, and I'll try and be getting back to you this afternoon, or someone from our team will. And if for some reason you have won one of these before and never got it, I just got a text from someone saying that where was the shirt they won last time. So it could have been something we messed up on or lost in the mail. So just I will make sure one gets put in the mail for you. Okay. So now, Darren, I'm going to make, we're going to just answer some of these remaining questions. If anyone wants to stick around to hear some of the questions people had, please feel free. Darren, I'm going to make you the presenter because you may or may not want to show some of the answers to these things. Okay, so let me go through these. One of them that I thought would be an interesting conversation was, someone was asking this, the version, I think it was Chris Jackson was asking, the version of Docker that you were running in all of this. Is this Docker 1.6, 1.7? What are we actually talking to in this environment?
This is all 1.7. Yeah.
It's 1.7. Okay. Cool. That was one question. Then another one was about.
Sorry, so say our minimum requirement is 1.6. And 1.7.1 just came out yesterday. Just let you know.
Cool. So there was another one that it's funny, this is one you and I have talked about at least a couple times, was is there any way to have hosts sort of pre-pull images? So Richard Silver asked this, is there any way to have hosts pre-pull images so that scaling is faster or failure is recovered faster, which is exactly the thing we were working on at DockerCon during the hackathon. Darren and I and a bunch of our team were at the hackathon at a DockerCon about 3 weeks ago, and we started a little project just for that called SureDoc, which really had only it had a couple of use cases. I don't know if you want to pull it up there and just kind of pull up
Sure.
the GitHub site, but basically the use case for SureDoc was, how do I clean up all these orphaned volumes and orphaned images from hosts when I don't want them anymore, and how do I pre-stage images that I do want to be on host? So basically a little caching surface. So it was basically caching hosts and garbage collection of images. So Richard, take a look at SureDoc. It's really a very small little project that we did in a 24-hour hackathon, and it's code that we're some of these concepts though are very much things we're looking to put into Rancher as well. So it was a good approach to kind of working on basically those two concepts. How do I cache images for quicker auto scaling so that I don't have to pull them all the time from Docker Hub when I bring up a new host. I can basically say anytime a new host gets added, automatically cache the latest version of image X. I don't know if you have SureDoc up anywhere, Darren. You could show it maybe at some point, but yeah, play around with that, Richard, and shoot us a note on the forums if you want. It's we'll sort of show you how that works. Okay, another question that someone was asking. Someone asked if they could ask questions about Rancher OS. So Igor, yes, you can ask questions about Rancher OS. We will do our best to answer those as well. So ask away. And then there was another question about the deployment that Kanwar asked. He said, can you have a new MongoDB instance connected to app2? So when we created that app2, he may have some data object changes. Can you have a new MongoDB app get created? Is that possible?
Not quite sure. You want to, so here I have like app2 and it's actually linked to the existing Mongo.
I think his question would be, could he create like Mongo2 from a new Mongo build or something?
Sure.
If you had a different Mongo and you had a new build, then you could link app2 to Mongo2.
Oops, you can link both of them or one of them. If there's a new one, yeah.
Cool.
That would work.
And then there's a good. I thought Jed Montgomery had a good question about.
Just one thing I wanted to point out, because we didn't really talk a lot of this. We didn't go into, it's kind of too many topics to cover. But basically, the way our linking works is all based off of service discovery, DNS. It's all dynamic. It's not actually like we do our best to emulate it and make it look like the standard Docker links, but it's actually completely dynamic. So you can have an application running and you can relink things. So you can add a new link and stuff like that.
Cool. There are a couple questions about, Willis just asked another one about volumes and portable volumes and stuff. Let me table that for a second to go through a couple things, Willis, and everyone who's asked about data volumes. I'm going to kind of jump back and ask all those questions in a row in just a minute. But you know, the Rasesh just asked a follow-up question to the last one where he wanted to know if he had more than one instance of the database, you know, which database is actually going to be used in this case. So I think it really just comes down to the links. So Rasesh, if you're having, you know, app, in this case, what Darren's showing here, app is linked to Mongo and app 2 is linked to Mongo 2, you can have, you know, you actually specify specifically the relationships between individual apps and their, you know, and the link in the database that they're talking to.
Yeah, and so there's, you know, if you scale up a service, let's say I have a service, you know, it just has one container, then I scale it up to 4. Basically what's going to happen is, like, if you do a DNS lookup, you're going to get back 4 IPs. Like, it'll come back with 4 A records. So applications that know how to deal with, you know, like, you know, scale directly like that can take advantage of that. Most of the time people do scaling, you know, kind of through a load balancer. It's much easier. You know, that's why we have our load balancer. Yeah, so there's kind of a multiple ways to do this, and a lot of it just depends on the style of communication your app does, and if it can handle, like, talking to many things at once, or if it needs to go through like a load.
Okay, great. So another question that Jed asked was, you know, he wanted to know about accessing the CLI and how. So he said, to access the CLI, do you have to log in similar to the web login where permissions are limited? Just like in the example, you know, he wouldn't want to give permission to everyone to the prod environment as opposed to leaving open like a dev or Wild West environment or something like that. So how do you, you know, does the CLI have global rights, or is it also limited? I think you showed how you pulled the credentials and set that up. Do you mind just showing that again, Darren? You know, kind of how the credentials are set up.
So basically the credentials are tied to the environment. So right now when you go, so it's like I have a dev and a prod environment, and when I go and I create an API key, this API key is specifically for the prod environment, and it gives me full access to the prod environment. And then if I go to the dev environment and then go to API keys, that API key is for the dev environment. So the way
is it user specific as well? Like, is the API key
No.
specific to that user, or is it for anybody who has access to this can get the API key right now?
Yeah, well, you can only, okay, when you create an API key, you can only get it at the time you create it. So if one person creates one, nobody else can get it unless they, you know, share it manually. Because you can't, you create it and then you have to save it at that time. But the API keys are tied to the environment. They're not tied to the user. And we've actually gone back and forth on this, and we'd love to hear people's feedback. The reason why we've done it this way is, like, imagine you're using these API keys and you have some automation and whatnot, and then the guy who set up the API key, he quits. So you deactivate his account, and then suddenly production goes down. So we didn't want to tie the API keys to a user. We really wanted to be tied to the environment. But we're actually interested on feedback of, you know, what's really the right approach.
Got it. So but just to go back, so then the prod, the only people who could have access to that API key would be members of the prod environment. So within prod, if you just go back to prod and you clicked on access control for prod or manage environments or something, you control specifically which team, you know, so again, going back to how this works with your LDAP or AD or with GitHub in this case, you know, we would probably have an ops team that you invited as members of the prod environment, or ops for, you know, this application's ops team. So you can see how Darren did this. So there's an ops team in Rancher org that's been allocated access to prod, and they have access to, they can then pull that environment key to access it. So hope that runs. There was so Jed's feedback was that the way it's set up is very good, and tying to the environment as opposed to a user is the right way to do it. So there you go. There's one piece of feedback on
All right.
the internal discussion about it. Thanks, Jed. So there was you know, So there was a question on that, going back to the linking pieces. When we talked about linking the app2 to Mongo2, Marco had a good question. He said, will app2 be linked to Mongo2 via like DNS-name-Mongo2? Can we have an alias here so that app can connect to DNS name Mongo and connection goes to Mongo2? So can you set up some kind of a DNS service or a DNS entry that can be adjusted on the fly? And the answer
right, yeah. So we specifically, so this is when you go and you add a service, we have various types of services here. One of them, like when you click on just add service, this is just your basic your container-backed service. But other services that we have is the service alias, the load balancer service, and an external service. So what a server alias is, and I think this might be closer to what you're saying, is I can create a static alias here called like app. But then I can link this to app2. So if I then go and deploy app3, I can just update this one place and say, okay, app3 is now active as app1. So this does, it allows you to, instead of having to change like everyone who linked directly to the application, you kind of have this intermediate layer to change this before the other one. So that's one thing we have for DNS. The other is external service. And so when you look at external service, this is for like, let's say in production, let's say I have a Docker Compose template, and in the Compose template is MySQL. But in production, you're not, going to most likely run MySQL in the Docker, template. You're probably going to, you might have your own setup or RDS or something like that. And so what external service is basically, I have a DNS name and I just want to assign it to IPs. And shortly, I believe, not the release that we're not the 27, but 28, will have support for host names. Basically, it does a C name. It'll give a C name. So you can just put like the RDS host name in there.
Oh, you know what? Marco's question was actually a little bit different. So he's gotten back. I mean, it was along those lines, but he was actually asking, when you link to a service, can I put in something that basically says that, you may be asking for Mongo, but I want you to direct that to Mongo.
Oh, right, sure.
So yeah,
sure,
sorry,
yeah.
Link, dash Mongo : Mongo2, and that is supported. Marco.
Yeah, and
Maybe
so that is
sure that.
in our Jenkins example. You can see this directly here. It's like we call the services master and slave, but the container is actually looking for the name Jenkins. So you say link master as Jenkins. So this is standard Docker Compose syntax.
Got it.
Okay.
Hopefully that answers your question, Marco. You can definitely do that. Okay, so good questions. Lots more coming. Thanks. I'm glad that answered your question. So there was another question about that sort of fits into still linking. Is there a way to link containers over different services in an environment? Ludwig Königsberger asked, and I hope I didn't butcher that, Ludwig. But the question was basically, I have two services. They're running in different. I'm assuming they're running in different projects. Ludwig, is that your question? So I'm running. I have one service running in say Prometheus and one service running in my prod. And somehow I want to link those two things together. I want services across these different projects to be able to talk to each other. So do you want to take that on, Darren?
Yeah. So right now, basically, you can only link to services within your project. So it is definitely on the roadmap to remove that limitation. That limitation is actually completely superficial. It doesn't actually matter under the hood the way we manage all the data and everything. So we will allow you to basically link services across projects and then additionally across environments. Now, environments will come a little later because going across environments requires a lot more authentication and you can look at it as almost like IAM. You need finer grained controls of who's allowed to consume what services. But to be honest, a lot of times when people are going across environments, they might just be exposing out a DNS name or an IP, and then you can use external services that I showed just a little bit. You can use external services to kind of map those between the two environments. But what you will see in the shorter term is for sure is the ability to link across projects.
Cool. There's another question that I think is very tightly connected to Compose that Richard Sugg asked. Oh gosh, almost an hour ago. Richard, sorry it's taken so long to get to this. How do you manage secure data? In the Compose file we showed, which was in GitHub, you had Jenkins username and password just exposed in the Compose file. How can Rancher allow him to keep secure data out of source control, available to containers, but not available to other users who may have access to Rancher? It's a great question, Richard. One we've actually been thinking a lot about. So, Darren, do you want to tackle that?
Yeah, I mean, so we hope to do a lot in this area to really help you better manage the secure data. The approaches that people do today is pretty much environment variables or by mounting in files. And they have their pros and cons, but basically the environment variable one, what you can do is, so let's say I have this here. I can create an environment variable, and I'll just call it password. Okay. So if I don't actually put a value, like, because let's say like, the value should be foobar or whatever. If I don't actually put in a value here, I just put the key, then this is just Docker Compose behavior, that it will look at the current environment, like the current environment that you're running in, like your shell environment, and it will look for the value there. And so what you can do is you can maintain these files. Here's the password that needs to be filled in, and then the kind of the operator, whoever is running the actual deployment, will then have to supply it in the current environment. So that's one approach. The other is by mounting in files, which you see quite a bit, and so we can do this too, which is volumes, where you have something some config file, and then you bind mount this in as my app config or something like that. But this approach does have the downside that this file has to exist on the host. So you can use, configuration management or other approaches to do that. So that's kind of what exists today. So all of this, like whatever I'm saying, is just kind of standard Docker stuff. Rancher is not really adding anything additional. We will be looking at, like, it's really a really highly requested feature is basically secrets management, is having a secrets management solution.
Cool. So I want to get to this data storage questions. That there were a couple that were asked over the course of the session. So one person, Kanwar, asked, and he said, during the core build, how does Rancher allow configuration volumes for data that can be used by user containers? And then another one, Willis just asked, are there plans for portable / shared volumes? Maybe you can just talk a little bit about that, both of those, and talk about. You may want to talk a little bit about what we're working on the storage side.
Yeah. I mean, so there's a lot going on here. This is all in the works. So volumes becomes a really, pretty big topic. So one thing I will talk about is how you can do data volumes with like scalable services. So one of the problems you have is, let's say I have, so in my template here, let's say the slave here actually wants a data volume. Okay, so we're going to call it some data thing. It uses some image. And then the slave here, you say volumes from data. So basically, this will use volumes from the data container. Now, this introduces some interesting scaling problems. Like just how do you scale this? Because what does it mean if I say slave, I want to be now 2 containers? What does that mean for data? Does data stay 1 and then I have 2 slaves? But obviously, if it's a data container, it needs to be on the same host. So then how do I actually scale these things? And it gets kind of complicated. And so what we've done is we've introduced a concept called sidekicks. It's not a new concept or anything, but basically we use a sidekick approach. And what you can do is you can say in the labels here, like IO Rancher sidekicks data. Oops, spelled that wrong there. You can say sidekicks data. Now, once you say that the data container is a sidekick to slave, this changes completely the scheduling behavior. What it will do is it will now deploy slave and data in a pair together. If you're familiar with Kubernetes pods, it's very similar. Like you have these 2 containers that are kind of tightly coupled together that get deployed as a unit and get scaled as a unit across hosts. So we do a lot to help kind of manage the kind of just data containers in general, like this approach because it's really common. So when you do basically when you do an upgrade, then you only like upgrade the new slave container, but not the new like you'll deploy a new slave one, but not a new data container. Okay, so that was a little bit like I don't know if that was actually directly answered, but I wanted to talk some of the capabilities because the data volume stuff gets kind of complicated on how you schedule it and orchestrate and things like that. But the second part of that question was about what about like portable storage and things like that, and we're doing quite a bit right now. Yeah, of volumes. We're doing quite a bit of work right now. There's a project.
We can't talk too much about it yet. We want to keep it. I mean, keep an eye on for the next week or so. We're going to be talking certainly in the month of July, a lot about kind of what we're working on the storage side. It's pretty cool. You should see, more cool stuff from our team later this month on specifically portable shared volume type of areas. So definitely, as a company, our focus is pretty consistently on the infrastructure side. I mean, we have to do a lot to implement a full solution for users to make this stuff work. But if you can tell, I mean, what we really put our brains to work on is how to make infrastructure services like networking and storage and load balancing and all of these pieces work really well together, so that when you go and do want to spin up a compose environment, it works the way it's supposed to. And so there was actually a question from Rasesh on networking. It's just asking, how is the overlay network of Rancher helping in the load balancing component? How are these pieces, sort of connected? And obviously that's really a lot of where, the magic comes in, as the networking piece, is ubiquitous, and sort of as you get real container networking, things like service discovery and load balancing, work together pretty magically. As I say, spin up the service and deploy it. Spin up. You can see, not in this exact one, but in maybe in the example of the production, application we deployed, the load balancer isn't talking to containers. It's talking to services. The services are exposed on the network. The network is, everywhere, within Amazon in that case, or within different clouds, and all of this stuff is portable. It's re-implementable anywhere. So you're not tying yourself into a specific cloud API. You're not tying yourself into a specific, infrastructure stack. I mean, you really have, this open portable infrastructure stack of the network and the, the load balancer and service discovery and storage that float just like Docker above everything that's happening in the actual provider you're using for infrastructure. And that's where, in a lot of ways, the big change is coming with Docker and Docker infrastructure. It's this portable. There's another question that I think someone had asked about, how are we, let me see if I can find this in all the questions. There's just been so many questions. Is Rancher going to use Docker's native multi-host networking when it goes mainstream, currently in experimental, or are you using your own implementation? Olivier, I guess it is actually, Olivier Robert had asked that question. Darren, do you want to talk about sort of how we're working with Docker's new, kind of approach to networking?
Yeah, so from the very beginning of all the Docker networking, all that work, we've been very actively involved in the design and things of that. And so so the networking is experimental in 1.7. Hopefully it will not be experimental in 1.8. It will actually become like the mainstream feature, and we will basically support any Docker networking plugin. Whether or not like the Docker one becomes our default, like because we have our IPsec right now, that's yet to be seen. There's some particular advantages of the approach that we're doing right now, in that it is encrypted and quite fast. What becomes like the default in Rancher is kind of yet to be determined, but we will for sure support any networking driver that exists or whatever.
Cool, and it kind of goes to just our approach too. I mean, the idea with Rancher is really to have a great implementation of things like networking and storage and all these things, and then a framework that makes it really easy to take those and put them into real production. So, the stuff we're talking about like LDAP and AD and, hooks into these different services are they all kind of go together. It's tough to say we do. Jed Montgomery had asked a couple questions earlier. He had a good question back over an hour ago as well, where he said, you've talked about swarm integration and you already have machine and compose support. How would Rancher, specifically the agent, work with Mesos and possibly Marathon on top of the resource abstraction provided by those tools? And the answer is it would work really well. I mean, we see a lot of use cases where people are looking at something like Mesos as as an underlying DCOS kind of thing, and then Rancher, Docker, these pieces sitting on top of resources. So that's one way that people are deploying it. There's other use cases where people are asking us, can we use Mesos as a scheduler within Rancher? So I really, in a lot of ways, I have a lot of empathy for users right now, because there's a lot of innovation happening around containers, and it's happening from just so many different directions that kind of building out something that you can get going with is not easy. And that's really what we wanted to try and show today. Was not the most advanced case, not the most complete case of how everything could possibly work together, but really just something that if we could set it up, we figured if we could set it up in an hour, and it turned out 2 hours, but we could set it up in 2 hours, and get something that was good for a team, let you connect it to sort of your core components. You kind of understand how this was all coming together and sort of the direction we were thinking about. In our build environment, which we'll probably be talking about in our next meetup, we're going to dive into some of these concepts in more depth. I think our next meetup will be in August. What we're going to do, we're going to kind of drill in with the drone team at Drone.io and talk about kind of how running some serious build scale stuff out is working for our team. And we're using drone. We've been using drone for the last few months to do builds, and where we do, we're talking about release candidates sometimes every day or a couple times a week. How we're doing that, how we're automating our testing. So we're going to kind of we'll have a couple guys from our ops teams sharing some examples, and then I think the goal in these meetups, and we certainly hope all of you can make it to as many as you can attend, is to really just share best practices, share what we're experiencing, give everyone a chance to share what they're doing and ask questions. We're going to look at, I think it's a great suggestion someone made today about having more of a chat window where everything can happen, or maybe an IRC channel, or maybe there's a better way to set up the GoToWebinar to be able to handle open chat between users, so and let people answer each other's questions as we're going too. So we'll keep looking at ways to make these better and make this sort of work really well. I think we've answered. Well, there's a couple more questions that kind of just come in. So Marco, you had asked a question about the shared data volumes. I just want to address that real quick. So you said, will shared data volumes work over NFS? So the two containers on different hosts use the same data volume located on network-file-system network-file-system server. Bear with us in the next week or so. We're going to be talking about some of the very similar use cases, or almost exactly that use case. So we haven't made any announcements today, but yeah, I think that's something that there's clearly a lot of demand for, and people are very interested in. How would something like NFS work with Docker as they start to use it in different ways. Okay, with that, I think we're going to call this. And as always, thanks so much, everyone, for attending. We'll be sending out recording information to everyone that attended. We'll also be sending out information about our next meetup with that. So if you made this one, you can put the next one on your agenda and your calendar. And Darren, thanks a lot for bearing with us and dealing with the reboot of your machine in the middle of the event. Yeah, again, and check all the information on the beta out on our website, and check out the new docs and the forums, and hopefully we will see you all next month at the next meetup. Thank you so much for attending. Thanks. Bye-bye.